7.5, day 3 today. We spend quite a bit of time on this stuff. Today is not too bad. We are talking about the intersections of arcs and angles. When we have an intersection, in this case it looks like two chords, intersecting, and they have an intersection inside the circle. We also have a case where we have a secant and a tangent intersecting, where the intersection is on the edge of the circle. And we'll see a case today where we have two secant, or maybe a secant and a tangent line, where the intersection is outside of the circle. So we're talking about three different things today: inside the circle, on the circle, or outside the circle intersections. And it's pretty easy to figure out measures of arcs or angles. So it turns out that if we have an intersection of two lines or segments inside the circle, then the angle is equal to half the sum of the intercepted arcs. So let's say I'm looking for the measure of angle 1 here. Well, if you guys have learned anything this year about angles, tell me about this other angle on the other side. They're the same. They're vertical angles, right? We know that. So what we need to look at is we have to look at their respective intercepted arcs. So angle 1, if you were to smash it closed, it would include this measure of arc AD here. And on the other side, its vertical angle friend would intercept arc BC. In order to figure out the measure of angle 1, it is half the sum of these two intercepted arcs. So the measure of arc AD plus the measure of arc BC. It's half the sum of the arcs. So angle 2, again, there's angle 2, but we have to consider its vertical angle friend. It intercepts arc AB and arc DC. So if I want to find the measure of angle 2, it's going to be half the sum of arc AB plus the measure of arc BC. That's all very formal, but really I think it's easier to just think the angle is half the sum of the arcs. And so if you can remember the angle is half the sum, then this becomes a very easy little equation to write down. So let's just look here at number 2. Number 2 says I want to find the measure of angle STR. STR is right here. And because that's what I'm trying to find, I'm going to call it X, just for simplicity's sake. So I want to find the measure there, angle X. Well, my formula is the angle equals half the sum. Well, my angle is X. So X equals half the sum of its two intercepted arcs. So here's one arc, and here's the other arc. So what should I write down? 112 plus 186. All right. Super simple. I'm just going to plug this into my calculator. Instead of typing 1/2, I'm just going to use the decimal 0.5 and 112 plus 186. So I'm just doing 1/2 times 112 plus 8, and we get 149. So half the sum, very easy. Angles are easy. But finding the measure of the arc is going to require you to write something down, okay? So you don't get it wrong. Here we are trying to find, on number 4, the measure of arc LK. So this one, I want to figure out the arc measure. But the formula is still the angle equals half the sum. What's our angle here in number 4? 62. So that's our angle measure. So 62, the angle equals half the sum of what two arcs? Yeah, I'm going to call X and 74. All right, so there's our arc LK and our arc JM. All right. So requiring, because our X is sort of inside our formula, we're going to have to solve for X here. How do you want to deal with the 1/2? Distribute is the first choice. It's not the best choice. Multiply by 2. Very good. I can multiply both sides by 2. What's 2 times 1/2? Not 0. 1. If you double a half, you get a whole. So that cancels out nicely and disappears for us, and we have 2 times 62. What is 2 times 62? 124 equals now X plus 74, and now how do you get X by itself? Minus 74. Super easy to do. We're going to get 50 degrees for our arc measure right there. So please write something down today. Number 6. We are trying to find, again, the measure of our QT. If I'm trying to find the measure of our QT, that's what I'm going to call X. I have this other arc mark of 95. Where's the angle that I need? QUT. I need QUT. How do we figure out this angle measure?
No, you just do 101 minus 70.
That was the answer, 101, yeah. All right.
Well, yeah, 180 minus 70.
There we go. So we have this 79-degree angle. We have this 79-degree angle, and it's a linear pair to this angle over here. So I'm just going to do 180 minus 79, which is 101. So now my angle is 101. So 101 equals half the sum of what plus what?
X plus 95.
X plus 95, or 95 plus X. All right, how do you want to deal with the 1/2? Times by 2 on both sides. So we get 202 equals X plus 95. And subtract 95, we get 107. Beautiful. So your job today is to identify, is my intersection inside, then it's half the sum. No. So we also need to figure out if we have an intersection on the circle. But the nice one here is you already know how to do this. So I just want to review for a second, because it's always good to refresh our brains here. I have a circle. The center of the circle is present. Please stop talking. What kind of angle did I just draw? A central angle. Good. And if the measure of my central angle is 120 degrees, even though it's clearly not, what is the measure of its intercepted arc here? 120 as well. All right. But if I have an angle whose vertex is on the circle, what kind of angle is that called? Inscribed angle. That's an inscribed angle. What's the measure of the inscribed angle? 60. Okay. All right. So even though my picture is clearly not to scale, it's just a good reminder that an inscribed angle is half the arc measure, okay? This is the same thing. Angle 1 here is an inscribed angle. Its vertex is on the circle. And so the angle is half the measure of its intercepted arc. So the measure of angle 1 is simply half the measure of arc BA. And the measure of angle 2, so angle 2 right here, is simply half the measure of its whole intercepted arc, which in this case is quite a large arc. It is a major arc, BCA. All right, so it's still just half the measure of its intercepted arc. So let's look at 8 and 10. So, on number 8, we want to find the measure of angle DBC. That's this angle right here. I'm going to call it X is what we're trying to find. The measure of angle DBC. What would it be nice to know to find that angle measure? The arc that it intercepts? Okay. So if I know this arc, then I can figure out the angle. Well, what's that orange arc going to be? Good. 360 minus 192 is?
168.
168. So our angle is half of 168, which is 84. All right, let's look at number 10. All right, number 10, we're trying to find the measure of arc K and M. Very big, major arc here. So we want that entire arc. Lots of ways to do this problem. What is this 23 talking about?
The line. Like the angle on the line.
The angle, yeah, that 23 is just this little tiny angle right there.
So then it's 180 minus 23. Find your angle.
So it's an inscribed angle, which means I could find the arc that it intercepts here? Okay. Or,
You do 180 minus 23 and then just multiply by 2.
okay, so 180 minus 23. So Vic is saying we can find this other side. If we know the angle is 23, what's the green angle over here?
157.
157. All right, and so my angle is half my big arc, which I'm going to call X. So what do we have to do to find the arc measure? Multiply it by 2. So X equals 314 degrees. There are many, many ways to do this question. So, Kaylee, what you said is also how we've done it. We've doubled this arc and subtracted from 360, which is another way. Patience, Padawan. All right, last one is when we have an intersection outside of the circle. So here we have 2 secant lines, and it turns out that it's the same formula for all these cases. The angle is half the difference of the intercepted arcs. So measure of angle A right here. The angle is half the difference of these 2 arcs. So 1/2 the measure of arc CE minus the measure of arc BD. It is half the measure, half the difference of the arcs. What's it going to be for this second case where we have a tangent line and a secant line? 1/2 the measure of arc BD minus the measure of arc BC. Good. And then for 2 tangents, again, the tangent means it's touching in one single place here, but the same formula applies. It's half the difference of 2 arcs. What's the first arc? BDC, the measure of arc BDC. It's a major arc, so we need all 3 points there, minus the measure of little bc, yeah, the little minor arc. So here the angle equals half the difference, DIFF, half the difference. All right, let's look at number 11. We want to find the measure of angle KLM. That's right here. So I'm going to call it X. So X is half the difference of what minus what? Yeah, 140 minus 66, half the difference. We're always going to do the far arc minus the near arc, as in far away from the angle minus the close one, okay? So 140 minus 66. And half of 140 minus 66 is 37 degrees. Let's look at number 12. Number 12 says we want to find the measure of angle BCD. So that's right here, this little angle way up here. So x is, again, going to be half the difference. The far arc I know is 67, but what is this arc BD right here? How do we find that arc? Okay, good. So you saw the diameter. Remember, we pay attention to diameters. Those are very useful. There's 180 degrees in that semicircle. So 180 minus 67 minus 94 equals 19 degrees. So that little arc mark is 19. And half of 67 minus 19 is 24 degrees. Any questions so far? No. All right, we have half the sum, half, or half the difference. Last two here. We're only doing two. I know, like, we could do all 8, but no. It's okay. All right, we want to find the measure of arc QU. So again, when you guys are finding the arc measures, you need to write something down. You got to write down your setup. We want to find the measure of arc QU right here, so I'm going to call it X. What's my setup for this? Good. Again, the formula is still the angle is half the difference of two arcs. So 35 is my angle measure. It's going to be half of x minus 46. How do you want to deal with the 1/2? Times by 2 on both sides, so it goes away. So we get 70 equals x minus 46. And then we need to add 46. Good. So we get 116. Beautiful. Questions on that one? The last one we're going to do is 18. All right, number 18. Again, we're looking for an arc measure, and we're trying to find arc MK here. I'm going to call it X. And again, the setup has to be the angle equals half the difference of two arcs. So what am I going to write for my setup here? Okay, 56. I heard it. Thank you. All right, 56 equals half of, what am I going to do inside the parentheses? 160 minus x. And this is really important. It has to be the far away arc minus the close arc. Far from the angle minus the near to the angle one. We're going to double it. We're going to multiply by 2 on both sides. So what is that? 112 equals 160 minus x. And then what do you want to do? Subtract 160. That gives me negative 48 equals a negative x. And then what do we need to do? Divide by negative 1. Good. So we get x equals positive 48 degrees. All right, ladies and gentlemen, your job is to decide, is it half the sum, half, or half the difference? And that's it.